The objective of this video is to review how to identify and analyze functions and discrete and continuous functional relationships. On 1 through 4, we're asked to use the graph shown to answer the questions. Number 1, list the ordered pairs. Well, you can see on the graph that we have several points. In fact, if I count them up, I've got 1, 2, 3, 4, 5, 6 points that are plotted on this coordinate plane. And I'm asked to, in number 1, list the ordered pairs. It doesn't really matter what order you list them in. I usually just work from left to right. So I'm going to start with this point in the third quadrant. To get to that point from the origin, I have to move left 5 and then down 4. So it has the coordinates of an x value -5 and a y coordinate of -4. And that's because I moved left 5 in the x direction and down 4 in the y direction. Remember, an ordered pair is always written in parentheses with an x coordinate first and then a y coordinate second. Okay, so that's my first point. Let's go to the point that's on the x-axis. Okay, so to get to that point, I moved left 5, but because it's on the x-axis, it has a y value of 0, and that's because it doesn't move up or down at all. Okay, the next point is in our second quadrant. To get to that next point, we have to move left 2, so left 2 in the x direction, and then up 1 in the y direction. Okay, moving on, I'll go to the point that's on the y-axis. Because it's on the y-axis, we don't move left or right at all. It has an x-coordinate of 0, but we move up 6. Okay, we've got 2 more points to list. Okay, the next point here in the fourth quadrant, I have to move right 3 and then down 4. So it has an x-coordinate of 3 and a y-coordinate of -4. Okay, the last point in the first quadrant is located at a +7, and then up 2 is a +2. In number 2, I'm going to take these ordered pairs and create a mapping. To do that, I'm going to list all the x values in the left oval and all the y values in the right oval, but you do not repeat any of the values if they repeat. So notice here that we've got a -5 and a -5. I only need to list that once. Then we have a -2, a 0, a 3, and lastly a 7. For my y values, I've got a -4, 0, 1, 6. I've already listed -4, and the last one is 2. Okay, but if I leave it like this, I don't know what x values correspond to what y values. So I need to finish by drawing lines or arrows connecting the corresponding values. So -5 goes to -4 and 0. -2 and 1, 0, 6. 3 goes to -4, 7 goes to 2. Okay, number 3, domain and range. Domain is the set of all the x values. So I'm simply going to list off the numbers in the left circle. And range is all the y values. So I'm going to list off all of the y values found on the right circle of my mapping. Number 4, is the relation a function, y or y not? To determine if a relation is a function, you look at the x values of the relation. And we've got 6 x values that we listed in number 1. For a relation to be a function, all the x values have to be different. But you can see in number 1 that we have an x value, -5, that repeats. Okay, because we have a repeating x value, this relation is not a function, and that's because the x values are not all different. The x value -5 repeats. Number 5, which of the following graphs does not represent y as a function of x? This is just a fancy way of saying which of these graphs is not a function. Okay, we just talked about what makes something a function or not when you're looking at the ordered pairs, but what if we don't have ordered pairs? What if we just have a graph? Well, there's something called the vertical line test that will check if a relation is a function or not. To use the vertical line test, we're going to start by identifying the shape that's on our graph. In A, we have a horizontal line that's graphed, and we're going to use the vertical line test to determine if that relation is a function. So I'm going to take a vertical line and draw it through my shape to see if it ever touches that shape more than once. Okay, so notice that in this graph, the vertical line only touches that shape once, so answer A is a function. Okay, for B, I have sort of this upside down V shape, and using my vertical line test, no matter where I draw it, it's only going to touch that V shape once. So answer B is also a function. Okay, look at C. I've got something like an oval that's graphed on my coordinate plane. And when I draw a vertical line through that shape, notice it touches more than once, so answer C is not a function. Lastly, number D, or letter D, I've got this U shape, and when I do my vertical line test, it only touches that shape once. So answer D is a function. So the only one that's not a function is answer C. Number 6, which of the following relations is a function? Once again, to determine that, we look at our x values. In number 1, we have x values of 3, 4, and 3. Because this x value 3 repeats, number 1 is not a function. Number 2, we have x's of 3, 4, and 5. They're all different, so this one is a function. In number 3, we have an x value that repeats, so not a function. And then 3, 4, and 5, they're all different, so number 4 is a function. I'm looking for the answers that are functions, so that would be answer 2 and 4, which is answer B. In numbers 7 and 8, we're asked to identify the domain and range of each graph. And you'll notice our graphs on numbers 7 and 8 are very different. On number 7, we have a line segment, and I know it's a line segment because it has 2 distinct endpoints. But on number 8, we have a shape that we call a ray because it only has one endpoint, and on the other end there's an arrow, which means that it keeps going on in that direction forever. Okay, so the process for finding domain and range on each of these is going to look a little different. Let's start with number 7. Because I have 2 endpoints, I know that my domain, which is all the x values, is going to be sandwiched in between my smallest and my biggest x values. To find those visually, it's really helpful to draw a box around your shape. And since the x-axis runs left to right, we're going to look at the left and the right side of that box. The left side hits the x-axis or has an x value of 0. The right side has an x value of 9. So x is sandwiched in between 0 and 9. It's bigger than 0 but less than 9. And notice next to the 0 there's a filled in circle, so it's equal to 0. For range, we're looking for our y values, and we know that our y-axis runs from bottom to top. So I'm going to start with the bottom of the box, which has a y value at 0, and the top of the box, which has a y value at 6. So y is sandwiched between 0 and 6. It's bigger than 0 and less than 6. Okay, once again, 0 has a filled in circle, so I put an equal to on the 0. On number 8, I can't draw a box around my shape because it keeps on going. So my box sort of goes off the graph here. When I go to find the domain, I know domain is x, and I can see that in the x direction, my arrow is going to the left off the graph. As x goes to the left, it gets smaller. And I forgot to, at the beginning, label my endpoint. That endpoint is at 9, -4. So the starting value is 9, and then it gets smaller than 9. Okay, notice the circle is not filled in, so it's not equal to 9. Okay, for range, I'm interested in the y values, and I can see that my arrow is going up. As y goes up, it gets bigger, and that beginning y value is -4. Number 9 and 10, same strategy here. Number 9 has 2 endpoints, so I'm going to box it in. For domain, I find the left side and the right side. Okay, the left side of my box, if I look down to my x-axis, I'm at a -2. And the right side, I'm at a +4. Okay, notice that the right side has a filled in circle, so it has an equal to on the 4. Okay, for range, I'm looking at the bottom of my box, which is at a y value of 3, and the top of the box, which has a y value of 4, 5, 6, 7. Okay, the top circle's filled in, so the 7 needs an equal to. Okay, number 10, I've got an arrow, so I'm going to draw my box going off the graph here. I can see my arrows going to the right. As I go to the right, x gets bigger, but what does it get bigger than? Let's label our endpoint. It's located at a -3 and a +1, 2, 3, 4, 5. Okay, so x gets bigger than -3, and I've got a filled in circle, so it's also equal to. Okay, notice that this arrow is going down, and as y goes down, it gets smaller than 5. If f of x equals x squared minus 5 and g of x equals -4x plus 2, find each of the following. Number 11, f of -3 equals. Well, this literally means what is y, the output, when the input x is -3 using function f. Well, f of x is listed here as x squared minus 5, so I'm going to take that and put it into y equals in my calculator. So x to the power of 2, or x squared minus 5, and then I'll go to my table by pressing second graph. So I'm looking for the output when the input x is -3. And here it is. The output is 4. For number 12, g of -2 equals literally means what is the output y when the input x is -2 using function g. g of x has a different equation. So I'm going to go back to y equals and type in negative 4x plus 2. Now I go to my table and find when x is negative 2, the output is 10. Number 13, if g of x equals negative 10, x equals. So to help you understand, once again, this problem though is a little bit different. This time they're asking for what x equals when the output y is negative 10 using function g. So g of x is negative 4x plus 2, and I already have that in my y equals. So I'm going to go to my table, but this time I'm looking for when the output y is negative 10. If I scroll down a little bit, I see that that's here when x equals 3. Number 14, find the range for f of x equals negative 3x squared plus 4 for the domain 1, comma, negative 2, comma, negative 3. Okay, I love setting up tables. I think it helps so much in the understanding of these problems. We're looking for the range, which is the y values, when the domain, which we know are the x values, are 1, negative 2, and negative 3. So I can take the function and put it into y equals, it's a negative 3x squared plus 4. And then going to my table, I'm looking for when x is 1. When x is 1, y is 1. When x is negative 2, that's here, y is negative 8. And when x is negative 3, that's here, y is negative 23. So for our final answer, we were asked to find the range, so I'm just going to list out range is equal to these values here, the y values of 1, negative 8, and negative 23. Number 15, which table, mapping, or graph does not show the relation negative 4, 2, 2, negative 1, 6, negative 3, and 5, 2? Okay, so notice we're given a set of ordered pairs and we have to match those up with 4 different relations to see which one does not match. Okay, so let's start with our first ordered pair, negative 4, 2. We can see in our table in answer A, negative 4, 2 is one of the points, and that's listed correctly. 2, negative 1, 6, negative 3, 5, 2. Those all look good, but we're looking for which one is not that same relation. Let's look at answer B. Okay, so starting over here, let's start with negative 4, 2. Negative 4 goes to 2. 2, negative 1, the arrow goes to negative 1. 6, negative 3, that looks good. And then 5, 2, that's our last one. B also looks good. Okay, so answer C. Let's start over once again. Negative 4, 2, that looks good. 2, negative 1, 6, negative 3. But look at that, 5, 2, 5, 2, and in answer C, it's 5, 1. That does not match. So that means answer C is not the same. We'll continue this review in the next video.